Today we're going to talk about energy, and in particular two types. Energy. Spelled that right. Okay. Two particular types of energy. But first, what is energy? Energy is defined by your textbook as the non-physical ability to cause change in matter. Now, what's that mean? Well, generally, energy produces motion or force of some sort. But that's not all it can do. It can also cause things like state change, melting ice, and things like that. I can do lots of other things, but those are just a couple of the most common examples. So that's what energy is. We're going to start off by talking about kinetic energy. And hopefully you know that kinetic energy is energy of motion. Just like the Xbox Kinect. You're moving around, that's why they named it that. They named it after kinetic energy. The other type of energy that we'll talk about is potential energy, and I'll just hold off on that until we get there. Kinetic energy can be found with this formula. Ke stands for kinetic energy, and it equals mv squared, that's a v, not an r, over 2. Sometimes it's written as 1/2 mv squared, but I think it's easier to just put it all over 2. It's mathematically the same. So mass times velocity squared over 2. And similar to work, which we just finished talking about, kinetic energy, or energy in general, is also measured in joules, because kilogram meter squared per second squared, that's basically a Newton meter. So kinetic energy is measured in joules, just like work was measured in joules. They're different, they're not the same, but they have the same unit, and so that can be a little bit confusing. So finding kinetic energy is easy if you know the mass and velocity of something. We can actually prove that it's possible to prove that work is the same as kinetic energy. I'm not going to go through that process right now, but if you're interested, it's on page 219 through 220 of the textbook if you want to take a look at it. But let's just say that we need to know that work and kinetic energy are essentially equivalent. We'll sometimes write things like this: the net work, that means total work, not the network, would be equal to the final kinetic energy minus the initial kinetic energy, or the change in kinetic energy. Network is the change in kinetic energy, and hopefully we know that change means final minus initial. So this is nothing new, this is nothing different. These aren't hard. It's a pretty easy thing. I guess I'll note this. This idea that we just talked about right here, this is called the work energy theorem. In case anybody ever asks you, you'll sound smart. And I might sneak that into the test somewhere. So remember that. Why not? So that's all I'm going to say about kinetic energy. It's a simple formula. I don't think most of you will have much trouble working these problems that I have for you to do. So let's move on. The other type of energy is potential energy. And those of you who've taken physical science, which is probably most of you, have talked about kinetic and potential energy before, but we'll start from the ground up again. Potential energy is actually a highly descriptive name. Potential energy is just the potential, like energy of potential, energy that could be used to cause a change in matter. could be used to move, or could be used to explode, or whatever. In particular today, there's lots of potential energy. There's like chemical, there's elastic, lots of different things. But today what we're going to talk about, we're going to focus on gravitational, because it's one of the easiest ones to model. Gravitational potential energy. So keep that in mind. Gravitational potential energy is what we're dealing with. I am going to note this, that the energy in a system is equal to the kinetic energy plus the potential energy in the system. Think about a ball being dropped off a cliff. When it's like if you're here holding it, then it has a lot of potential energy. Let's say 100, let's make up a number, but its kinetic energy is 0 because you're holding it still. When you drop it and it gets to here, well then here your potential energy, it still has it because it still has the ability to go down, is lower, and the kinetic energy is higher. And then right at the moment it strikes the ground, you have no more potential energy, and you have a great deal of kinetic energy because you're moving really fast. That's the idea, that the total energy in a system is equal to the kinetic energy plus the potential energy. So before we move on, we'll keep this idea in mind, let's talk about the fact that, remember from weeks past, Vf squared equals Vi squared plus 2AD is what we would usually say. But I'm going to say for a falling body, what's the acceleration for a falling body on the planet Earth? It's g, gravity. And instead of d, I'm going to put h for how high you are. Okay, and so hopefully this is familiar. This isn't anything new. Now, what I'm going to do is I'm going to multiply both sides of this by 1/2 m. Multiply both sides by 1/2 m. I can do that. I can multiply both sides by whatever I like. Look what we get when we do that. We get m Vf squared over 2 equals m Vi squared over 2 plus, when we do this, the half cancels the 2, so we get just plus mgh. Now, why did I want to do that? Well, what's mv squared over 2? That's kinetic energy. And so that's the final velocity. Well, where's the final velocity? That's right here. So we can substitute that. We can just call that kinetic energy equals mv squared over 2 plus, well, at the final velocity moment, your height is 0, so plus 0. So there we have just the kinetic energy equation. So that's kind of neat. So if that's the kinetic energy, and the total energy has to equal kinetic energy plus potential energy, then this must be the potential energy. So this is a very long-winded and somewhat convoluted way to tell you that the formula for potential energy is mgh, and this is gravitational potential energy. Like I said earlier, we're focusing on gravitational potential energy. So gravitational potential energy is equal to m times g times h. And there's really nothing tricky about that formula either. Notice it's still kilogram meter squared per second squared, which is still measured in joules. So I think you'll have a pretty easy time with the work today.